This is A2 Pure Mathematics Chapter 1 Algebraic Fractions. So sometimes we need to combine many fractions into a single fraction. Rather than this being an exam question in its own right, it's going to be a skill that you apply to a number of different exam questions as you go through the A2 Pure content. So just a few things to try and remind you about algebraic fractions and simplifying them down. You should have seen all of this before at GCSE, but just as a recap. So you must factorise before you cancel. So you can only cancel common factors from the numerator and the denominator. So always factorise that numerator, factorise that denominator, and any of the brackets that are common to both of them, then you can cancel them. The biggest misunderstanding that we see here is this. So you cannot cancel part of an expression. So that x there and that x there, they don't cancel out because this term at the bottom is actually x plus 2. This expression at the bottom is x plus 2. Therefore, we can't cancel across a plus or a minus sign. That's because this line here means divide, so it needs to be the inverse of division, which is multiplication. If we substitute 3 into here, so if we let x equal 3, we'd have 3 over 5, and that doesn't simplify down to a half. So that is something that you can do. If you're not sure when you've done some simplification, when you're doing your fractions, you can always just substitute a value for x into the numerator and the denominator of the original question, into the numerator and denominator of your simplified fraction, and see if you get the same answer. You should get the same. It doesn't change the final value. If we've got 2/4, that means a half. It doesn't change it by simplifying it down. So, example. You might want to pause the video here and have a go at simplifying this. So the first thing that you're going to do is factorise numerator and denominator. What we notice here is that we have a difference of 2 squares here. So please try and spot that. It is quite common when you simplify in algebraic fractions to see this, but you should be able to spot it straight away, and it does help. Once you've factorised something down, it's useful to maybe think, am I going to get a common factor? I mean, this one's easy to factorise here, but if you had a cubic, for example, it might be that one of the factors from the denominator gives you a hint on what that's going to be on the numerator. So that's something just to focus on as you move through this topic. So here we have x plus 2, which is common to both numerator and denominator, so I can cancel, leaving me with 2 over x minus 2. So today we're focusing on adding and subtracting fractions. These examples should look extremely straightforward. It should be something you've seen from primary school, but also all the way through GCSE. But I want you to really focus on the method that we're using, because we can relate to that when we're working with algebra later. What you've got to remember is algebra is a representation of number. So anything that you can do numerically, you can apply the same rules algebraically. If you can't do it to numbers, then you shouldn't be doing it to algebra either. This is probably what you saw when you were at GCSE. So we do A times D, C plus C times B, and then you multiply those two together. We do need to be careful because that's not the most efficient way, and I'm sure most of you worked out quite quick at GCSE that the lowest common multiple is the way forward, because it saves on simplifying things. So I'm not going to use 6 times 15 here to get 90. The easiest way to go for lowest common multiple is to look for the prime factor decomposition of each of the denominators. So this here is 2 times 3. 15 is 3 times 5, and because the 3 is common to both the 6 and the 15, I am only going to use it once when I'm looking for that common multiple. So we're going to use 2 times 3 times 5, which is 30. Adding those numerators together should lead me to there. Make sure you understand this step, because we're going to refer back to it. It's that bit that's important to understand. Pause the video, have a go at this one, and there's your answer. So this is more what we'd expect to see at A2. So we're expressing this down to a single fraction. This bit here, so this just reads as x belongs to the real numbers. The real numbers are integers or decimals, negatives, rational, irrational. So any of the numbers that you've worked with since you started learning how to count. So we have to put that on there because there are different number systems. So, but it's not something to worry about. However, when you're going through the second year exam papers, you will see that a lot. So we're going to keep putting it there just so you get used to seeing it. X is not equal to 0, x is not equal to a half. Obviously you understand what that means. In terms of doing this question, it's irrelevant, but we have to put that on there to make the question work, so to make this expression work, and I'll explain why as we go through. So the first step would be to factorise each fraction. So we've got 1 and then 3 over 2x minus 1, and then that x plus 1, none of that needs factorising. It's only this denominator on that third fraction that we need to worry about, so we take a 3x out. This is why we can't have 0 and we can't have a half, because if we put 0 into there or we put a half into the 2x minus 1 term, then we're going to be attempting to divide by 0, which will make this undefined. So that's why that is there, to make it work. Important point, a denominator will never need expanding out. So if you're lucky enough that your exam question has already factorised the denominator down, please do not start by factorising out that denominator. And similarly, as we walk through this example, I'm not going to do any more expansion on that denominator. It's only on the numerator where we'd need to expand something. I cannot stress how important that is. Just overcomplicating it when you start trying to expand things that don't need expanding. So we need to find a common denominator, and we want it to be as simple as can be. So think back to the 6 where we had 2 and 3, and the 15 where we had 3 and 5. So because the 3 was common to both of them, we only used it once. So looking at the denominators, the denominator on this one is 1, which is obviously common to everything. The denominator here is 2x minus 1, and here it's 3x, 2x minus 1. That 2x minus 1 is common to both of those fractions, so I am only going to use it once. I'm not going to just multiply these together. If you do that, you're ending up with a cubic and you're overcomplicating it. Again, it's going to make for extra simplification, but here, when you're trying to simplify it down, you've got to factorise it. So you don't want to start introducing cubics and quartics to factorise if you don't need to. Really important. The other thing that we've got here is 3x. So our denominator is 3x, 2x minus 1. And now we've decided that that is not going to change throughout the question, and our final answer will look like this with the numerator. So we need to work out what each of these fractions is going to look like, and it's just a case of spot the difference really. So this one doesn't have a 3x or a 2x minus 1, so it needs both of those multiplying into that denominator, therefore they need to go on the numerator as well. When we look at this second fraction, it already has a 2x minus 1, so the bit it's missing is 3x. So I need to multiply numerator and denominator by 3x. The bit in blue is what was already there. When you look at the final fraction, the denominators match, so I do not need to change it. So this is what we end up with. And now it's just a case of adding those numerators together, just like you did with the numerical examples. To do that, we do need to expand this bracket out. So I do need to expand numerators out, but I do not need to expand that denominator out. So now it sits just on its own, so combining all three things together. An important point here would be this plus sign. If it was a minus sign, that would apply to the whole fraction, and you will come across this in the exercises, so it is worth just pointing out now. If that is a minus sign, it applies to this full numerator, and this would become minus x minus 1, not minus x plus 1. So if this is negative in the middle, it applies to every single term on that numerator, so it just sits at the front of the bracket. Put a bracket around that. This reads as minus 1, so do watch for that. However, we don't have that in this question, so it can stay as plus. We're going to simplify that down, and then you have to ask the question, does it simplify further? And to check that, you need to factorise it. So if your numerator will factorise, it's worth factorising, and if it would simplify down, then we would expect to see a 3x or a 2x minus 1 here, which we don't. It's worth having it in factorised form, because the rest of an exam question probably would require you to solve this or do something with it, which is easier when it's factorised. And that's the end of that question. So here's our next example. Have a go at simplifying this down. So pause the video, have a go at simplifying it down, and I'll walk you through. Notice we've got this notation again here. We're kind of going to ignore that. We'll pick it up when we're solving the equation in a minute. So step 1 of factorise. The only thing to factorise here is the x squared plus 2x. So factorise out an x. come up with your common denominator. The x plus 2 is common to both of them, so x plus 2 will be a factor that we need, and then we need an x as well. So we've got x plus 2. This fraction is missing the x, so we get 6x over x plus 2. This one can stay as it is. And then we simplify it down by 6x minus 3. Remember that minus sign would apply to all the terms on this numerator. To finish it off, we need to factorise it, so I can factorise a 3 out and I get a 2x minus 1. It doesn't simplify any further because there aren't any common terms. Part B, hence. When you get the word hence, it generally means that you are going to use the working out that you've done in part A to apply it to part B. So all I'm going to do is replace this. I'm just going to check that that is exactly the same as we've seen in some exam questions. Sometimes they do a little tweak to get from part A to part B, but it isn't. It's exactly the same. So I can just replace this with the fraction that I have just found by combining them and let it equal 1. We're going to then multiply, as you would always do with an equation. I can multiply this up to the other side. Just remember here, we were working with expressions. Expressions don't have equal signs. These equal signs are just saying this is equivalent to that, this is equivalent to that. Possibly should have the identity sign here, so you've got the 3 lines to say that they're equivalent to each other as you work down. I can't multiply this up to the other side because there isn't another side. Here we have set it equal to 1, therefore I can multiply through. At this point I would expand both of those brackets out. I said before you would never need to expand out a denominator. It is not a denominator in this part of the question, so here I wouldn't need to expand it. Here I am going to need to expand it, which gives us a quadratic. And as we all know, when we've got a quadratic, we need to set it equal to 0, and then we would attempt to factorise it, or you could use your calculator to solve it if you can't spot a factorisation. This gives us the answers 1 and 3. At this point, this is the first time I'm going to consider what's called the domain here, so these values here, and I'm going to look at it and say, right, it wants values where x is greater than 0, both of those qualify, so I can stop. It might be that if we'd have had something like x was greater than 2, then I would ignore x equals 1 and just take x equals 3.